Okay, in this video, we're once again going to be looking at centripetal force. Okay, so we've talked about this before, how centripetal force causes circular motion. The centripetal force is always directed towards the center. The velocity is always going to be tangent to the circle. And so just going through, we got 5 questions to kind of solidify our knowledge on centripetal force. So once again, this is our main equation. It's not one that you'll find in your reference table, but I encourage you to draw it in there because you're going to see that your centripetal acceleration is equal to v squared over r, and then right below it you'll find the centripetal force is equal to mass times centripetal acceleration. So this equation right here is just a combination of those two. So it talks about centripetal forces are always directed towards the center or outside of a circle. It's always directed towards the center. In fact, centripetal means center seeking. So if you're swinging keys around or something like that, or something on the end of a string, you have to be pulling that stuff towards your hand. And as soon as you stop pulling it towards your hand, it no longer goes in that circular path. We look at number 2. It says if the velocity of a car is halved, the centripetal force required to keep in the path of constant radius is multiplied or divided by something. So a lot of the ways, the easiest way to do these is to make up numbers. So you got a centripetal force is equal to that mv squared over r. Now I'm just going to rewrite this. But now what I'm going to do is I'm just going to make up numbers. I'm not going to make it fancy. I'm going to make my mass 1, my velocity 1, don't forget to square it, divided by my radius of 1. And so if I go 1 times 1 squared over 1, I'm going to get 1. So now if I chop that velocity in half, so what I'm going to do is I'm going to keep the mass the same. So I'm going to leave this in orange. I'm going to leave the mass the same. I'm going to take my velocity though and make that 1/2 what it was before. Can't forget to square it, however. And then I'm going to keep my radius the same because it's still the same radius. So now when I do this, 1 times 1/2 squared divided by 1, that gives me equal to 1/4. And so it's going to be divided by 4. So it was 1, now it's going to be 1/4 as much. Number 3, what furnishes the centripetal force required to keep a satellite circulating the Earth? This is the link between centripetal acceleration and gravity, but it is the gravitational force. Gravity is trying to pull that object down to the Earth. The thing is moving so fast, though, that it is essentially falling around the Earth. Now, that same satellite orbit the same velocity on the planet with 3 times the force of gravity, the orbital radius will be multiplied or divided by. So for this one, what we're going to have to do is we take up the exact same numbers. So it now tells us that we're looking at the force centripetal and the radius. So if I do this, I go, all right, well, my centripetal force is equal to mv squared over r. And so my force is going to be 1, and then my mass is going to be 1, and my velocity is going to be 1. Don't forget to square it, and my radius is going to be 1. So 1 is going to be equal to 1. But now what I'm going to do is I'm going to make that centripetal force, that's going to have to be 3 times as much. So this is going to have to be 3. And so now I'm going to keep this the same. I'm still going to have 1, because 1's still going to be the mass, because that's not changing. The velocity is going to stay the same at 1 squared. So if it has the same velocity, I'm going to have to say, all right, well, what am I going to have to do to my radius to make that 3? And it turns out that I'm going to have to divide it by 1/3. So if I cross multiply that, I get 1/3 and 3. So it'd have to be divided by 3. And that one's a little bit trickier. Okay, you generally won't see one like that on the Regents exam. Okay, you're going to be more likely to see one like this. Yep. All right, so jumping to number 4, it says if the velocity, radius, and mass are simultaneously doubled, it requires centripetal force. So again, we're going to go base it off the exact same thing. Again, centripetal force, mv squared over r. So let's make up numbers. So we got 1 for the mass, 1 for the velocity. Don't forget to square it, divided by the radius of 1. And so that equals 1. Now we're going to double everything. We're going to double the velocity, radius, and mass. So we're going to go, instead of 1, we're going to make this 2. We're going to make this 2, but don't forget to square it. And we're going to make this 2. And so now you get 2 times 2 squared over 2, and you end up getting that it's going to be 4 times as much. So it's going to be multiplied by 4. So now it says number 5, if the centripetal, by the way, that should be not multiplied by 2, but multiplied by 4. I'm going to have to change that on the answer key. And lastly, number 5, if the centripetal force exerted on the object is multiplied by 4, the velocity of the object is doubled. The radius of the circle will. So here we go. Again, we'll do the 1 times 1 squared over 1 is equal to 1. And now what we're going to do is we're going to quadruple the force. So now this is going to be 4 times as much. And now my mass stays the same. The velocity of the object, though, is going to be doubled. So now it's going to be 2 squared, and we're looking for what happens here. And so now what we can see is, oh, well, if this is 2 squared, this is going to equal 4. So my radius is going to be the exact same. It's going to be unchanged. So this is a little more conceptual. This one's a little bit tougher to get. So if you have difficulty understanding this one, again, please come see me and we'll go over it. So everybody have a great night. We'll see you later. Bye.